We can begin by thinking about what is the smallest possible value for this expression. Since our 4 primes don't need to be distinct, we can choose to write this as equal to 2 to the 4th power. This term is even. This term is odd. Even plus odd is odd, so this can't be equal to 2 to the 4th power. This analysis in parity suggests that we can figure out whether this expression is divisible by a prime by checking to see whether the residual in the mod of that prime is equal to 0. So for example, if 3 is a prime that divides this expression, then the expression will be equivalent to 0 in mod 3. We replace 11 with 2, the mod 3 residual. This means m times m minus 1 is equivalent to 1 in mod 3. We can make a quick table for all possible values of m. We notice that the product of m and m minus 1 is never equal to 1 in mod 3, so there are no solutions, which means 3 is not one of our primes. To check to see if one of our primes is 5, we check for divisibility by 5. This means in mod 5, our expression is going to be equal to 0, which means m times m minus 1 is equal to 4. These are all possible values of m in mod 5. These are all the possible products in mod 5, and none of them is 4. So this has no solutions. Let's try the next smallest prime, 7. We need m times m minus 1 is equivalent to 3. Here are all possible values of m in mod 7. Here are all the possible products, and none of them are 3. So no solutions. Let's check to see if one of our primes is 11. It turns out we do have solutions for mod 11, so we know that 11 can divide this expression. Let's try the smallest possible value, which is 11 to the 4th. We want to solve for m such that m is a positive integer. Let's try m equals 121, and we'll compare it to 11 to the 4th minus 11. And we see that m equals 121 is too small. Let's try m equals 122. This is also bigger than 11 to the 4th minus 11. So m here is too big, and we don't have an integer value of m that satisfies this equation. Let's see if there's what other prime is going to divide our expression. We'll go to the next one, 13. So we want m times m minus 1 is equivalent to 2 in mod 13. We see that we can generate a mod 13 residual of 2. So there is a solution in mod 13, which means 13 can divide this expression. Since we want to minimize this expression, let's try the product of 3 11s and 1 13. Trying to ballpark our integer value of n, let's try m equals 132. Substituting in our expression, factoring, and we see that m is an integer solution and gives us the product of 4 primes. So our answer is 132.